Bismillahirrahmanirrahim. In the name of Allah, the most beneficent, the most merciful. I am Syeda Zuriat-e-Zehra, crew member of Community of Research and Development and a student of University of Engineering and Technology, Texla, Department of Electrical Engineering. I am going to present my paper in International Conference on Advances in Mechanical Engineering 2021, and the topic of my presentation or research is a novel intelligent model for COVID-19 detection using cuff auscultations and Hjorth descriptors. The co-authors are Engineer Misha Urooj, Engineer Kawal Habib, Sania Harim Khan, and Faizan Tariq. The table of contents include motivation, introduction, diagnosis, literature review, materials and methods, results, discussions, conclusions, references. Motivation. It was detected in the Chinese city of Wuhan and was reported to the World Health Organization on December 31, 2019. It has affected more than 50 million people and killed 14 million globally, and claimed over the lives of 2.53 million and affected over 114 million globally as of April 2021. People with a compromised immune system or elderly people mostly are more likely to develop serious illness, including heart, kidney failures, particularly kidneys or septic shocks, etc. Introduction. What is a coronavirus? Coronavirus or COVID-19 is an infectious disease caused by SARS-CoV-2 virus, or that is severe acute respiratory syndrome, or ARDS, acute respiratory distress syndrome, a family of viruses that affect respiratory tract or causes diseases from common cold to pneumonia. It usually lives in bats as it's transmitted from bats to humans and can transmit between humans via respiratory droplets. Most people who fall sick with COVID-19 will experience mild to moderate symptoms and recover without special treatment. However, some will become seriously ill and require medical attention. This virus can spread from an infected person's mouth or nose in small particles when they cough, speak, sneeze, sing, or breathe. Within 2 to 14 days of this contact, the newly infected person develops symptoms. And dry cough, weakness, fever are physical symptoms in mild to medium cases, while shortness of breath, tiredness, fever are signs of some extreme cases. People who have asthma are more susceptible to the virus and can become seriously ill as a result. Coronavirus was detected in the Chinese city of Wuhan and reported to the World Health Organization on December 31, 2019. And as we can see that in this figure, in December 31, China alerted WHO to several pneumonia cases. From January 7, France confirmed Europe's first coronavirus case. On January 11, China announced first death from coronavirus. At January 13, WHO report cases in Thailand. January 30, China alerts WHO to several pneumonia cases. February 2, first death outside China reported in Philippines. To February 7, Chinese doctor and whistleblower, he died. Until February 14, Egypt confirmed Africa's first case of coronavirus. Symptoms of coronavirus. The symptoms of coronavirus include shortness of breath, high fever, vomiting, pneumonia, coughing, diarrhea, etc. Currently, coronavirus is diagnosed using time-consuming and inaccessible RT-PCR, that is reverse transcription polymer chain reaction testing. But due to the lack of medical equipment, medical personnel, and healthcare facilities, such kit is not readily accessible. Novel coronavirus can be identified using machine learning techniques as well. Additionally, it can forecast the virus's nature around the world, but machine learning also requires a large amount of data to classify or predict this disease. Recently, artificial intelligence has been implemented in the healthcare sector widely. There are so many applications in the field of speech and audio. AI has created a space. It is used for the screening and early detection of different diseases, which could help in saving a large number of lives. Literature review. A computer system was developed by authors in one to detect COVID in two stages. For calculation, high-level data frames, mean and standard deviation were computed, and the results, and by using SVM classifier, yeah, the results show that the system achieved 92.7% sensitivity, 88.58% specificity, and 90.69% region under the curve. The authors in C3 used another method for pneumonia, childhood pneumonia diagnosis using a cough. By using a logistic regression classifier, the sensitivity and specificity of 94 and 88% was achieved. In the authors in of 6 presented CNN and transfer learning based automated detection for datasets of normal pneumonia and COVID-19 X-ray images. The results of this study demonstrate that by using deep learning, the accuracy, sensitivity, and specificity of 96.78, 98, and 96.46% was achieved. Convolutional neural network is a fast and efficient detection tool for COVID-19. So this method was used in Bhaval Victoria Hospital. By using chest radiographs, they found that the average accuracy, specificity, and sensitivity of 96, 95, and 96.24% was achieved. The proposed methodology of the detection of COVID-19 subjects is shown in this figure. The methodology works in basically 4 steps. The first step involves data collection, cuff auscultation recording, data repository, storing the signals or audio files in the data repository. The stethoscope fitted with a microphone recorded the cuff auscultations. Then, in the second step, the signal pre-processing and segmentation is done by the removal of, first of all, the DC component was removed by doing amplitude normalization and then using empirical mode decomposition for pre-processing. The third step involves feature extraction. For feature extraction, Hjorth descriptors were used, whose parameters include activity, mobility, and complexity. And in the end, classification was done using medium K nearest neighbor to classify dry cough, wet cough, and COVID cough. For data collection, we have designed low-cost and efficient auscultation sensor to gather the sound signals for the detection of viruses. The system includes a stethoscope, a sensitive microphone, an amplifier circuit, and a sound card. By placing auscultation sensor near the left or right lung, the microphone starts sensing cough auscultations. Cough auscultations are basically the cough sounds heard within the lungs to diagnose COVID-19. 3 kinds of cough signals were collected, that is wet, dry, and COVID cough. A wet cough, also known as productive cough, is a cough that produces mucus, whereas a dry cough doesn't produce mucus. During the compilation of cough auscultations, each participant produced 25 seconds long signal. Later, we divided the signal into 5 seconds so pre-processing and segmentation could be done easily. The frequency range of cough auscultations was 1 to 2 kHz, and the sampling frequency of experimental signal was set to 8 kHz by using Nyquist sampling theorem. Dataset. The dataset was collected from local hospitals and it includes 29 females for COVID cough collection, 62 for wet cough, 57 for dry cough, and 49 males for COVID cough, 51 for wet cough, and 65 for dry cough. In total, the overall collected dataset consists of 1579 cough auscultations. The following figure shows the raw signal for cough auscultations, that is COVID cough, dry cough, and wet cough. And it can be seen from this figure that the three cuffs are different from each other. The next step after collecting the cuff auscultations is pre-processing. In pre-processing, the first step is DC removal, DC offset removal. DC offset is a mean amplitude displacement from zero. If the resulting waveform appears above or below the zero line, there is probably a DC offset. DC offset is a potential source of clicks, distortion, and loss of audio volume. The second step in pre-processing is normalization, that is amplitude normalization. It is essential for algorithms to model data accurately. It maintains the ratios and general distributions in data and keeps the values across all the columns within a certain limit. We can also apply normalization to single or multiple columns in the same data set. So the pre-processing, the following figure shows the pre-processing signals after the normalization and DC offset removal is done. Signal segmentation. The next step is signal segmentation. Signal segmentation is done to segment out the region of interest from a time domain signal. Cuff auscultations have strong amplitudes in power spectrum where frequencies are less than 2 kHz. So here we have segmented this region from a pre-processed cuff auscultation signal whose frequency range is 8 kHz with the help of empirical mode decomposition. Now, what is empirical mode decomposition? Empirical mode decomposition, or EMD, is an adaptive time-space analysis method suitable for processing series that are non-stationary and non-linear. Empirical mode decomposition performs operations that partitions a series into intrinsic mode functions without leaving the time domain. These modes provide insight into various signals contained within the data. The EMD algorithm is based on the premise that every non-stationary and non-linear signal is made up of a variety of signal intrinsic oscillation modes. EMD decomposes a pre-processed cuff auscultation into its constituent intrinsic mode functions as shown in the figure, which are locally orthogonal, and a leftover signal known as residual signal. The D part shows that the segmented cuff auscultation signals for dry cuff, wet cuff, and COVID cuff. Feature extraction. For feature extraction, Hjorth descriptors are used here. Also, they are also called as normalized shape detectors, which consist of parameters that are used to define the complexity of biomedical signals. Hjorth descriptors or Hjorth parameters are indicators of statistical properties used in signal processing in time domain. These parameters are activity, mobility, and complexity. These descriptors are widely used in previous studies as a measuring tool for human health using EEG, electroencephalography, time domain signals, lungs, sounds, etc. Activity shows that the magnitude variations in the signal, its small value signifies a small peak intensity difference. Signal mobility is the first derivative that shows the variance of signal gradient, while frequency variations are shown by complexity. The following figure shows the activity versus complexity and mobility versus complexity. The next step is classification. Classification in machine learning is a supervised learning approach in which the computer program learns from the data given to it and make new observations or classifications. Two classifiers are used here called as weighted k nearest neighbors and decision tree. The weighted k nearest neighbor algorithm is based on the supervised learning approach. KNN assumes new and existing cases which are identical and assigns new case to the category nearest to the existing labels. The decision tree algorithm can be used to solve regression and classification problems. It learns basic decision rule from training data and creates model using this data for prediction of variables, class, or significance. In this study, weighted KNN classifier took 472.22 seconds to train the Hjorth descriptors with a prediction rate of 29,000 observations per second. The total misclassification cost of the prediction value is 3, as shown in the figure. The weighted KNN used 10 nearest neighbors per prediction value. This classifier scored 99.8% sensitivity, 97.82% specificity, 99.8% accuracy and precision of 99%. The false value for COVID cough is 0.8%, while true value for COVID cough is 99.2%, and for wet and dry cough are 100% as shown in figure. Fine decision tree classifier took 10.145 seconds to train the Hjorth descriptors with a prediction rate of 10,000 observations per second. The total misclassification cost of the prediction value is 80. Fine decision classifier uses 100 splits while splits criteria was Guinness Diversity Index. This classifier scored 93.93 sensitivity, 92.02% specificity, 94% accuracy, and 93.03% precision rate. And TPR and FNR denotes true positive rate and false negative rate. From the results, it was found that the weighted cannon achieved 99.8% accuracy, and fine decision tree classifier achieved an accuracy of 94.4% and 93.03% precision. Performance evaluation of Hjorth descriptors. The results show that dry cough has the largest activity and mobility, while COVID-19 cough has the highest complexity. The activity parameter of dry cough shows uniformity in time domain, while COVID cough mobility value shows that the most spread and variation. Due to the amplitude normalization phase of pre-processing, all reported parameter values are very small. Hjorth descriptor benefits from reduced cost computing and fast feature extraction, as it has 3 parameters in comparison to other approaches. Thus, the time domain Hjorth descriptor values are much smaller but much more consistent. Conclusion. The COVID-19 virus is a terrifying label all over the globe. Several COVID-19 related experiments have been conducted, particularly the screening process to monitor the disease's transmission. Lung sounds and COVID cough auscultations can be used to test for lung abnormalities in patients. Here we have proposed an intelligent machine learning model for COVID-19 detection using cough auscultations collected from Pakistani hospitals. It is an efficient and accurate diagnosis, effective, and it is cost friendly, no danger to human health, and it will assist people in Asian countries in predicting the existence of COVID-19 in the initial phases. We have used here weighted cannon and fine decision tree classifier, which results in a cumulative accuracy of 99.8 and 99.4%. Here are the references.